Hello, everyone. So this is the last section into this chapter. It is partial fraction decomposition. So first, we're going to see adding or subtracting rationals and simplifying. And what we're actually going to be doing is going backwards. So last year, when we had two rationals and we were adding them together, we would find a common denominator, make the common denominator to be able to put them together, distribute, combine like terms, simplify any which way we can, and this would be our answer. Well, partial fraction decomposition means we're actually going to go backwards with this. We are actually going to start with this and show that these are the two rational to get there. Okay. All right. So we're going to go case by case. Make sure you identify what case you're doing before you go to the next problem. This is where many students make a mistake, is they automatically assume it's like case one and not the other cases. So to solve, what we're going to do is we're going to factor the denominator completely. We're going to set fraction equal to the sum of the multiple fractions, one for each factor as a denominator. For numerators using A, B, C, depending on how many factors there are. We're going to clear the equations of fractions, and then we're going to choose nice values of x to solve for A and B, okay, if it is possible. So we're also then going to be using some elimination or substitution to help us with A and B, okay? So what did that all mean? So let's go step by step. One says factor the denominator. As you can see, the denominator is already factored into x plus 1 times x minus 2. So what we're going to do is we're going to set our equation, or our rational here. And what we're going to do is set it equal to both of our rationals, each with a factor. So since there's two factors here, we're going to have one that is over x plus 1. We're going to add, right? We're going to keep it simple on ourselves and keep an addition here. And the other one is x minus 2. Now, what we don't know is we don't know what's in the numerator there. So how we're going to break that up is we're going to say A plus B. And we are now going to solve for A and B to allow us to be able to figure out what two rationals added together give us this 5x minus 1 over x plus 1 times x minus 2. Okay, now we rewrote it. Okay, so we have the factors. Now what we're going to do is clear the equation of fractions. So if we look, we need a common denominator. We need a common denominator of this x plus 1 times x minus 2. So what is this missing? This is missing our x minus 2. And this one's missing our x plus 1. And we know, so we do not change the value of the fraction. Whatever we do to the bottom, we must do to the top. All right. Now that we have a common denominator, now we can actually just look at the numerators. So let's do that now. So if I just look at the numerators, I have 5x minus 1 equals A times x minus 2 plus B times x plus 1. Next, I will distribute these out. So you get 5x minus 1 equals ax minus 2a plus bx plus 1b. Now this is going to be the different situation that you're used to. What I'm now going to do is put my x's together and my constants together. Okay, there's my x term, there's my constant. So I'm going to put those together. So I end up getting ax plus bx minus 2a plus b. All right, so why did I do that? Because if you look at this correctly, I'm going to make this all sort of an addition piece. Okay, now I'm going to change this to addition, so 5x plus -1 equals. Here I'm going to factor in x, guys. And what's funny is in this term, I'm actually going to put the x in the back. Usually when we factor something out, we put it in the front. But I have a trick for you guys. So I'm going to have a plus b times x. Now here, again, I'm going to make this addition. So this is the adding of this -2a plus b. Now, why did I do that? And this is where I need my highlighter. Because if you look, this a plus b that is in front of x will equal 5. Okay. Of course, I don't have another highlighter, so I'm going to have to use something else. And this constant right here equals this constant. So now I'm able to write a system to help me solve for a and b. So right now I have a plus b equals 5. And I have -2a plus b equals -1. Now what's nice about this system right now is our b's are the same, so I can subtract straight down. So 1 minus -2. Well, 1 minus -2 is 3. So we have 3a. Our b's canceled. That's the whole idea of subtraction. And then 5 minus -1. Well, 5 minus -1 is 6. So when we solve, what does that mean, guys? That means that a equals 2. Well, if a equals 2, I can substitute back in to get b. Well, if a is 2, 2 plus what is 5? So b is 3. Now, what does that mean for my answer? It means, and I'm going to draw and divide that up so you guys can see, 5x minus 1 all over x plus 1 times x minus 2 equals, now be careful, a is on top of this factor, b is on top of this, so equals 2 over x plus 1 plus 3 over x minus 2. And we just broke it up. We went backwards. And that's our answer. All right. So this is not a new case, but in this question, you see that we have to factor that denominator first. So I have x plus 5 all over. And when we factor that, we get 2x plus 1 times x minus 1. So we run into the same situation as we did before by having our two factors, which means we're going to split that up, having 2x plus 1, and the other one is x minus 1. Again, these are two factors. We have an a and a b. Remember the next step? The next step was common denominator. So this one's missing an x minus 1. Whatever widget in the bottom, widget at the top. This one's missing a 2x plus 1. do that to the top, because now that if we have common denominators, we can ignore them and look at the numerators. So x plus 5 equals, I'm still going to write this all out. I know eventually some of you will do this a little bit quicker and do that distributing before you write this down, or distributing right away, I should say. Plus 1. Okay. I'm going to distribute ax minus a plus 2bx plus b. Remember what we did next? We put our x's together and our constants together. So x plus 5 equals ax plus 2bx minus a plus b. All right, I'm going to factor out that x, so x plus 5 equals a plus 2b x plus negative a plus b. Okay, I'm not going to highlight this time. We're just going to look at it. So what is the value in front of this x here? Well, it's 1. So that means a plus 2b equals 1. And our constant is negative a plus b equals 5. Now, solve our system. In this case, because they're opposite, we can add straight down. So a's cancel. We get 3b equals 6. So b equals 2. Now I get to substitute back in. It does not matter which one you substitute into because it should equal the same. I'm going to go on the bottom though and go negative a plus 2 equals 5. So negative a equals 3. So that means a equals negative 3. Now when we write our answer, remember we're saying what equals what. And remember to put the right variable on top of the right factor. Okay? So I'm going to give myself some space. That means x plus 5 all over. Now I'm going to write my original problem down, which was 2x squared minus x minus 1 equals a. Well, a in this case is negative 3 all over the 2x plus 1 plus 2 over x minus 1. Now, some of you might be thinking, what if I split this and I put the x minus 1 over here and the 2x plus 1 over here? Well, if you did, the negative 3 will still be on top of the 2x plus 1. The 2 will still be on top of the x minus 1. Okay, case number 2. So remember, I said you want to watch out for the cases. The denominator has a repeating linear factor. Now, what does it mean by repeating? Well, because this is squared. This is x plus 1 times x plus 1. So how does that differ compared to case 1? Well, what happens is because we're splitting the factors, but we have to keep in mind of that multiple, it's going to look a little bit different because now when we split it, we know that we have an x plus 1 factor and an x plus 1 squared factor. So it's almost like a chain within itself. Like, so you have the inside and then the outside there, okay? Now again, this is still, we're going to stick with addition, and if it happens to change later, we will. Now in this case, just like in case 1, we just did an x to the first, right, in the denominator. Even though this is squared, we're going to think of the inside. Okay, and this will make more sense the next case we do. So in this case, we still have A and B. All right. Now, let's talk about our common denominator. Well, lucky for us, those are both common there. So we're just missing an x plus 1. And whatever we did on the bottom, we must do to the top. All right. Now we have common denominators. We can just look at the numerator. So 5x minus 1 equals a times x plus 1. And what's great is that this one, we have b. Okay. Let's distribute. Ax plus a plus b. All right, let's see this. We have 5x minus 1. I'm going to, since we don't have two x's here, I'm just going to keep in mind that we have a times x plus a plus b. Okay. So a is 5. That's nice because a is 5, right? And then a plus b equals -1. Well, if I plug that in, that must mean that b is -6. Okay, that one was a little bit easier. So all in all, we have this 5x minus 1 all over x plus 1 squared equals a is 5 over x plus 1. Now, we could say plus -6, or in this case, we could subtract 6 over x plus 1 squared. And that is case 2. Let's practice one more of the case 2 just to see what else we need to find. Okay. So we got a factor. What do you guys notice in this one right here? Well, first of all, I have a GCF, so let me get rid of the GCF, leaving x squared minus 2x plus 1. And then I notice that this is x minus 1 squared. So when we do this, how many factors are we looking at? Well, when we do this, we have to actually split it into 3 factors, right? So we have x, we have plus the inside, which is the x minus 1, and then don't forget that repeating, right? So I have to have this x minus 1 squared. Does everyone see that? This is the repeating like we did in the last example. So in this case, we have a B, a C. Next step, common denominator. So here we're missing an x minus 1 squared. This we're missing an x and an x minus 1. So x minus 1. And here we're just missing an x. All right. This is getting a little bit crazy, huh? So let's look at what we have. We now can look at the numerators. 3 equals a times x minus 1 squared plus bx times x minus 1 and plus c. times x. All right. So unfortunately, in this case, we do have to multiply this out first before we multiply by a. So 3 equals a. Now we have x squared minus 2x plus 1. Okay, that I know that by going back here. You can do your box method, you can do your FOIL, whatever you need, but that is where I got it from. Let's see. Now I'm going to distribute everything out. So 3 equals a x squared minus 2ax plus a plus b x squared minus bx plus cx. Okay, in this case, because I have x squareds and x's, I'm going to put them all together with their like terms, okay? So I get 3 equals ax squared. I have a bx squared. Now I get my x's. I have a minus 2ax minus bx plus cx, and then plus a. So see how I group them together? There's my x squareds, my x's, and my constant. Now I'm going to factor out those x's. Remember, in this case, I'm putting them in the back so that way I can see what the coefficient will be. So 3 equals a plus b times x squared plus negative 2a minus b plus c times x, and then plus a. So what are the things that we have going on? Well, do we have an x squared term here? No, we don't. So that means a plus b equals 0. Do we have an x term here? No, we don't. So negative 2a minus b plus c equals 0. But what this is a constant. Lucky for us, that means a equals 3. And that allows us to go and substitute back in to make sure we have everything. Because if a is 3, b must be negative 3. And when we plug into the bottom here, we find out, let's see, let's just do this, right? So negative 2 times 3 minus negative 3 plus c equals 0. So that's negative 6 plus 6. Oh, plus 3, right? Plus 3 plus c equals 0. So c must be 3. Great. And of course, I left no room for my answer. Probably should have shifted this over and had my answer there. But you know what? I'm going to write it on the side so you guys can see. So we get 3 over, let's write the original problem down, which was x cubed minus 2x squared plus x. Now, what did we get? We got a is over x, so 3 over x. We can say minus since it's a negative 3. That's our b over the x minus 1. And then our c over the x minus 1 squared. Yay! All right, next case. All right, here's what happens. What I wanted you guys to notice in case 1 and case 2 is that our factors was always x to the first. But in this case, we might get a factor that is x squared. Now, do not confuse this with the multiple factors, meaning the x minus 1 squared. Okay, that is a different case. In this case, we're going to deal with an x squared. Well, what that means is that our numerator is going to be in the form of a x to the first plus b. So always think of it as one exponent lower. Okay. All right, so what does that mean? Well, luckily, they already have this factored for us. If we're lucky, they'll always have it factored. So when I break this up, okay, I'm going to do this step by step so you can see this. You see that I'm going to have an x minus 2 as one factor and an x squared plus 1 as another factor. You see that? Okay. Well, what is in the numerator above the x minus 2 is just our single variable. Remember, one less exponent. If this is x to the first, well, that would be x to the 0, which is just 1. Where in this case, we have x squared, right? So we must have an x here. So we have bx plus c. You guys see the difference from what we did before? So when we have an x squared here, we're going to have like a bx plus c. And we're going to solve for a, b, and c. Okay. Now we need to do our common denominators, of course, just like we normally have. So we get, this is missing an x squared plus 1. And this one's missing an x minus 2. All right. So common denominators, we can look at the numerators. So x, or 5x squared minus 5x plus 5 equals. Now this is a times x squared plus 1 plus, here's our tricky thing, bx plus c times x minus 2. So if you see right here, guys, this is going to be whether you like to multiply by box or FOIL, that's going to be an extra step there. 5x squared minus 5x plus 5. I'm going to distribute that a. I get a x squared plus a. Okay, I need to FOIL this. So we get plus bx squared minus 2bx plus cx. And then my last term of negative 2c. I FOILed that quickly in my head. If you have to do the box method, then do that on the side. I'm going to put all my like terms close by each other. 5x squared minus 5x plus 5 equals. So we have an ax squared plus bx. I'm going to squared, sorry. We're going to put all of our x's together. So, yeah, we'll do minus 2bx plus cx, and put our constants together, which is a minus 2c. Okay, very good. Now let's factor out 5x squared minus 5x plus 5. So we get a plus b x times x squared plus negative 2b plus c times x plus a minus 2c. Now I have our three parts. I'm running out of room. All right, so right here we have a plus b. That's our x squared, so there's 5 of them. we have our negative 2b plus c equals negative 5. And then we have our a minus 2c equals 5. Okay, so we would have to do some rearranging, substituting in, whatever you would like to do to be able to, I mean, we could solve for b here and then substitute in and then deal with that, or you could do your matrices stuff. You can choose whatever method you want, but if you want, try it right now. I'm just going to give you what I found. A is 3, B is 2, and C is negative 1. I'm going to turn my paper again just so I can show you how that answer looks. So we get 5x squared minus 5x plus 5 all over our x minus 2 times x squared plus 1. All right, what that is our a value is 3 all over the x minus 2 plus, now be careful, it should be bx, so 2x plus c, so negative 1, and that is all over the x squared plus 1. Okay, so that is case number 3. Oh, there's a lot here, huh, guys? All right, so let's see if we can break this down more. We have to factor the greatest common factor, which is x. So we get x squared minus x plus 1. Now, why am I on? There we go. Okay. In this case, though, this cannot be broken up anymore, right? There is nothing that's multiplied by itself to give you 1, but add to give you negative 1. So when we split this up, we see the two factors. We see x, and we see x squared minus x plus 1. Okay, this is just a single x on the first, so that means I'll just put 1 up here, which is just a. But because this is x squared, remember, I have to have this bx plus c. Again, 1 exponent lower. So here I'm missing an x squared minus x plus 1. Here I'm missing an x. Okay, in this case, it might be easier for me just to distribute as I'm writing down. So I get 3 equals, and I'm going to distribute the a out there. So a x squared minus a x plus 1 plus, and then I'm going to distribute that x out. So that's b x squared plus c x. Combined or put those like terms together. So ax squared plus bx squared minus 8x plus cx plus 1. Factor out. So I get a plus b times x squared plus negative a plus c times x plus 1. Oh, what did I do, guys? This is why the distributing stinks right there. I wasn't supposed to put 1, I was supposed to put a. That makes more sense. Whew. Okay, so I know that a plus b equals, well, there's no x squared over here, so that's 0. Then I know that negative a plus c, there's no x terms over here, so that's 0. And what's nice is a, which is our constant, is 3. Well, if I put that back into the top one, that means b is negative 3. And that means that c is 3. Nice. Hey, I have room this time, guys. So 3 over, let's do the original problem, which is x cubed minus x squared plus x equals, it's our a term, which is 3 all over x. Now, this is where sometimes it gets tricky with that subtraction. Because remember when b was negative, I put subtracting, but that messes things up if I bring the subtraction down. So in this case, what I want you to do is stick with the addition, stick with the b being negative, and then the c is positive. X squared minus x plus 1. Again, if I bring this negative down here, I actually am factoring out a negative here too. So instead of messing with that, keep it as addition and say minus 3x plus 3. Okay. One more case, right? One more case. You know what we're doing? We're putting case 2 and case 3 together to see what happens. So this is going to get long. Okay, this is going to get very long. So instead of doing that last example on the other page, let me see. No, we could do that actually. Yeah, this one's going to be more in depth. So let's just do this one, and then we won't do example 8. Okay, if we need to, we'll do it in class. All right, so what I see here is I see this x to the 4th plus x cubed plus x squared minus x plus 1. Okay, now I want you to look at these factors. I have an x, I have a multiple of x squared plus 1. So remember what that means. That means there's going to be 2 of these, the inside and itself. So we have, again, I'm going to put down the bottom first. We have x plus, then we have the inside, which is x squared plus 1. And then we have the outside, or itself, which is x squared plus 1 squared. You guys see that? Okay. Now, keep in mind, looking at the exponent in one lesson. So since this is just x, the top is just a. But since the bottom here is an x squared, it means I'm going to have that bx plus c. And here, excuse me, I have that x squared again, so I'm going to have a dx plus e. Yes, we went out to d and e because we already used b and c. So this is what it's going to look like. This right here is because of the multiple, and this is because we're dealing with an x squared on the bottom instead of an x to the first. All right, ready? It's a long one. Next step, common denominator. So this one is missing an x squared plus 1 squared. This one's missing an x and an x squared plus 1. Ugh, this looks messy. But as long as we take it step by step, we won't lose any steps. All right. Whew. What I am going to do here is we're going to just look at the numerators, right? So I have x to the 4th plus x cubed plus x squared minus x plus 1 equals. here's what I'm going to do, guys. I'm going to put down this a, but instead of actually saying x squared plus 1 squared, I'm going to FOIL that out or do my box, depending on what you guys want to do. So x squared plus 1 times x squared plus 1 is x to the 4th plus 2x squared plus 1. And remember, that's where that came from. Then we're going to add, I'm going to have this bx plus c times, what I'm going to do is I'm going to distribute that x to there so I don't have to worry about that. So x cubed plus x plus, and then I'm going to distribute this x out. So it's dx squared plus ex. I still have more to do, right? So here's what we're going to do. We're going to distribute that a. We're going to box or FOIL, depending on what you want to do there. So x to the 4th plus x cubed plus 2x. Oh, what am I doing? X squared minus x plus 1. We end up with a x to the 4th plus 2a x squared plus a plus, I'm going to FOIL, so we get b x to the 4th plus b x squared plus c x cubed plus c x, running out of room. Okay. dx squared plus ex. Now what? Remember, put like terms close by each other. So I have x to the 4th plus x cubed plus x squared minus x plus 1. Okay, I have a x to the 4th plus b x to the 4th. Now I'm going to do all my x cubes, right? So I have a plus cx cubed. Now I'm going to do my squares. So I get 2a x squared plus b x squared plus d x squared. Now my x's, so plus cx plus ex, and then our constant of a. Now, if you guys had to, anytime you wrote one down, you could cross it off to make sure you're not missing any. That's going to be up to you. Whew. Let's factor out. All right. So we have a plus b times x to the 4th. You know what? As I do this, I'm going to write down below what that means. That means a plus b equals, what's that number in front of x to the 4th? 1. Now we have only cx cubed. That's nice because that tells me c is 1. Now we have plus 2a plus b plus d x squared. So what does that mean? That means 2a plus b plus d equals, and this is x squared, so it's 1. Get c plus e. So c plus e is -1. And a is 1. Well, that's nice, right? Because we have a is 1. Well, if a is 1, b must be 0, Okay. Now, if A is 1 and B is 0, so that would be 2 plus what is 1? So D is -1. We already have C, so we need to find out E. So if 1 plus what is -1, so E must be -2. All right, so when we write that, the good thing is that we just need to plug in these numbers, okay? So what this equals, and just to save me some room, guys, I'm not going to write the question itself out this time. A is what value? A is 1, and that's over x, plus B is 0. Now, do I have to say 0x? No, I can just say plus C, which is 1, all over x squared plus 1. Then this one here, but I'm going to be careful with my negatives and stuff, right? So I'm going to say plus, and instead I'm going to say -1x. Now you don't need to say -1. You could say -x, and then E is -2 all over x squared plus 1 squared. Awesome. Now, tricky thing is, if this were a multiple choice question, we might see this part right here, because if we factor out a negative and made this a subtraction instead of addition, it would have been x plus 2 over x squared plus 1. But this is also why we show our work, so that way I can give you points for this just in case this is the answer that shows up on multiple choice. Okay, that was a lot of work. If you want, you could try this one out by itself. At least let me factor it to make sure you have the factoring down. Now, let me just show you something. If this were x squared plus 6x plus 9, we know that we would factor that as x plus 3 squared, right? Okay, but this is x to the 4th. So when we have x to the 4th plus 6x squared plus 9, you need to realize this is x squared plus 3 squared. Okay, so when we look at this, we're looking at x cubed plus 5x minus 1 all over x squared plus 3 squared. And so when you look at the factors here, guys, it's multiple and it's x squared. So remember that the first factor then is just that inside. And then the second factor is itself. So it's the squared part. So of course, since this is squared, this is going to be an ax plus b. This one's going to be a cx plus d. Okay, and then you can do that math going forward. But I at least wanted to show you how you can separate. Pay attention to each of your cases. Is it a multiple? Is it not a multiple? Is it where x squared's in the denominator? And how does that play? Hey guys, have a good day.